Hello, everyone. Welcome to another wonderful webinar Wednesday. Thank you for joining us. Today, we've got Nick from AgEagle joining us, talking a little bit about how to solve your agronomic challenges with multispectral and thermal drone data. But before we get to Nick, just a couple of friendly reminders. Number one, this webinar is being recorded, so if you guys need to step away, whatever the case may be, you'll get a link with the recording at the end of the video. At the end of the webinar, there will be a Q&A session. Please go ahead and put your questions in the Q&A section down below. That way we can see it, not miss anybody, because if you do put them in the chat, sometimes we will miss the questions. And also at the end of the webinar, we have a very short survey, maybe 15, 20 seconds, 30 seconds at the most. If you would please go ahead and fill that out for us, we would greatly appreciate it. This way we know if what we're doing is what you guys want to see. And we also can take suggestions from you guys as to what you want to see next as far as webinars are concerned and topics. With that being said, I'm going to go ahead and introduce Nick. Please welcome Nick Martin. He's a regional sales manager at AgEagle Aerial Systems and an FAA certified remote pilot operating a drone service business of his own. He has over 250 flight hours and has provided digital images, maps, and technical consultation to his clients for more than 5 years. In addition, he has 15 years of experience in sales across diverse industries, including drone and commercial aviation. Nick, thank you so much for joining us. Appreciate the time that you've taken to do this today. And with that being said, you go ahead.
Thank you so much, Gio. I appreciate the introduction there. I'm going to go ahead and share my screen, and we're going to get down to business here. All right, so I just want to confirm real quick that you guys can see what we are seeing here. Oops, sorry about that. Okay. Welcome, everyone. Just a quick shout out to our friends at Drone Nerds. Thank you for putting this together, providing us an opportunity to connect with everyone out there and tell you guys a little bit more about what we do. So we're here to talk about agronomic challenges. We're here to talk about multispectral data and MicaSense multispectral cameras. So this is a little bit about us. This is AgEagle. That's the company that I work for, and these are the products that we make. AgEagle has 3 different organizations. SenseFly, which makes EB drones, fixed wing drones. MicaSense, which makes multispectral sensors, which is what we're going to discuss here today. And also we make a fleet management drone software called Measure. Get into that a little bit later. So drone mapping. I'm sure that a lot of people on the call today are 107 pilots and might be offering mapping solutions to clients today. So you're probably familiar with some of this, but we're just going to talk a little bit about why drones are so cool and why we're all here talking about them. So agronomic challenges have existed for as long as farming has existed. Certainly there's multiple ways to get information about the crops in your field. People used to do it more with, and people still do it with satellites. There's Sentinel-2, Sentinel-3 Earth observation satellites from which farmers and agronomic specialists can pay to download data and imagery from. There's essentially that's the most expensive option. There's also manned aircraft here, crewed aircraft. These are another decent option, but somewhat limited for agronomic specialties because they are very expensive. They're not that repeatable, and sometimes they're affected by weather. And so we get into drones here, which is what we're doing, and you offer very high resolutions, very high repeatability, and low susceptibility to clouds, weather, and much lower costs. Satellites, are limited manned aircraft are a little bit more limited. Drones are the least limited. This is just a back-to-back picture from one of the Earth observation satellites that's orbiting Earth currently, called the Sentinel-2. You can see here some of the differences in resolution. 10 meters per pixel versus 1.2 centimeters per pixel. Certainly, I don't need to tell you guys that higher resolutions are better, and that is what we're offering with MicaSense cameras. So this is the workflow. The way I like to look at this is the workflow gets a little bit harder as you move to the right. The easiest thing to do is capture imagery from your drone or with your drone. The second easiest thing to do is process that imagery. And the most difficult thing to do is analyze that imagery. So the workflow is pretty straightforward. You're setting up a camera on a drone and having it capture, via automated triggers at certain GPS waypoints. You're using a drone mission planner to plan and control your flight path. And that's something that AgEagle's measured ground control can certainly help with. At AgEagle, that's our software of choice to control drones, create missions and maps. After the flight, you go ahead and retrieve that data card from the drone. You go ahead and put it in your laptop, process those TIFF images into an orthomosaic and begin to analyze that data. So here we have a couple output examples of how we go about analyzing that data. Here's a small section of an almond orchard. All of these outputs were created using a MicaSense camera, and each one is providing a piece of insight into the canopy of these almond trees. Over at the top left, this is an RGB composite, this is a fairly standard picture. I'm sure a lot of people are familiar with RGB imagery. Chlorophyll map is where we go here towards the right, where we get a near infrared image. This is all processed in whatever GIS application you guys are using today. Continue on towards normalized difference vegetative index, the NDVI map. This map here includes a red edge image analysis as well. NDRE analysis is best for measuring biomass potentials and yield potentials of a lot of different crops. And right here, we're looking at almonds. Continuing on down, this is a soil analysis view, essentially near infrared. This is a composite infrared. This is a digital surface model here. And DSMs this is showing a 3D model of the plant canopy and identifies high and low spots in the field. There's a lot of layers that are possible to capture by using a 5-band sensor, like a MicaSense sensor. Our latest Red Edge P sensor enhances the spatial resolution even further through a technique called pansharpening, which we'll talk about. And this enhances machine learning applications that you might be already using to do things like automated crop counting, stand counting. So when you have a higher resolution picture, you're more able to allow a machine learning algorithm to reach its full potential. Pansharpening is a really cool image processing technique that right now MicaSense is one of the only companies to offer pansharpening imagery. So pansharpening, what is pansharpening? Panchromatic band sharpening. Pansharpening is an image processing technique which combines a high resolution panchromatic image with a multispectral image of lower resolution to improve the overall image's resolution, kind of merging information to create a much sharper image. Pansharpening is useful to create very high resolution RGB composite maps and also high resolution agricultural indices like NDVI and NDRE. So what's the benefits of some of these bands here? So Chlorophyll content, this is a red edge band that we're looking at right here. Red edge, NDRE. Chlorophyll content in a plant is best observed through the red edge band. The red edge band is about the edge of the visible light spectrum that we can see with our eyes. NDRE is an index that makes use of chlorophyll information in the red edge band. So the NDRE map is sensitive to how green a leaf appears. There's variability in leaf area, and it can also pick up on soil background effects. Let's remember that chlorophyll has a maximum absorption in the red wavelength. So red does not penetrate as far into the plant structure. Conversely, green and red edge bands are not absorbed as much. And so they penetrate much further and allow you to glean more useful information because their more red edge and green bands are much more sensitive to chlorophyll reflectance values. High values on the NDRE map represent high chlorophyll values. So you can see here on the cursor side, on the right side of the image, this part of the field is looking pretty good. Some of these lighter shades of areas, the plants are, they might be struggling a little bit. And this is best seen through an NDRE map relative to an NDVI map. One of the best ways to understand chlorophyll content and plant vigor is repeating NDRE maps throughout the growing season over the same field. So let's talk a little bit about drone mapping applications. It's important to just convey that drone mapping can be utilized in any part of the crop life cycle, from land preparation to irrigation to looking for weeds to where to spray. These are all areas where you can get better information using a MicaSense camera. They can be used to monitor and improve various agricultural aspects. Multispectral analysis can be useful at really every stage and is often used in crop management and as well as crop research. Multispectral maps can be used to accurately estimate how much crop yield the farmer will get. This is best done through a digital elevation map, which is what we're looking at here. This is a DEM map. Elevation and plant height can be really good measures to assess yield estimates. And this is predominantly how farmers are using yield estimates. High resolution multispectral data can produce very high resolution DEMs, digital elevation models. The ability to create this high resolution map allows users to identify high and low spots essentially in the field. And when a part of the field is not producing what it needs, the area can be treated as necessary to improve yield. It's all about finding the information. Multi-season measurements of a field can also show unproductive parts over time that do need attention or should be better prepared ahead of next year's planting season. Multispectral analysis helps lots of growers identify crop diseases as well. The vegetative index NDRE, which we talked about before, is used in this example to identify a tree that's potentially affected by stress or disease. Some other kinds of maps won't reveal this information, whereas an NDRE map is more likely to reveal this information. Precise multispectral imaging enables detection of subtle variations in plant vigor, such as trees that might have, if you look over here, trees might have a little bit more dust on the leaves due to the proximity of the access road, like a dirt road nearby. And this fundamentally will reduce the productivity of the tree, and you're able to see minute variations like that through an NDRE map. Professional cameras like like MicaSense cameras allow you to capture extremely high quality, high resolution images with a ground sampling distance typically of about 8 to 10 centimeters per wavelength, per band, when flying from 400 feet AGL. So you're able to differentiate between plant canopy, the shadow of the plant, and the soil as well, as opposed to just combining all of these elements into a single pixel and providing an average, which is something we don't do. What we do is we yield a much more accurate representation of crop health and plant vigor. High resolution information is available, and when it's available like that, you're able to use machine learning algorithms to their full potential to help you identify the plant species and also analyze the health of it, see what's going on. So this is kind of a fun slide here. What we're looking at over on the left, or this is actually a rice, or sorry, this is a rice paddy. This is a peach orchard. So over here on the left, you can see, and this is just the RGB composite image, fairly routine. The blue image here in the middle shows a map that was captured about 10 days after a third-party fertilizer application. So the farmer hired someone to spray this field. These are NDRE images, and the highest NDRE values appear in blue, which is biomass to chlorophyll variability. So what you can see here is this kind of striping along the field. And this is important information for you as a grower. This could be evidence of poor or uneven application of fertilizer, and this can affect yield in the long term. And also, you're paying someone to fertilize a field, and they're not probably fertilizing the entire field. You can see actually on the left here that this spray partner didn't spray this part of the field. He might have ran out of juice, and instead of going back and refilling the tank, he just decided to go home. The farmer would never know that unless an NDRE map was produced here. So it actually helps a little bit with accountability, if making sure that you're getting your money's worth for your spray partners. Over here on the right is an NDVI map of a peach orchard. And what we want to show you here is on the left is the field in a bit of distress from a nematode infestation. And what this is this is pre-application for nematode. And on the right here is post-application for nematode. So you can see there's a lot more plant vigor, there's higher chlorophyll content, and it's simply said, it's just more consistent throughout the field. So this farmer is going to have a much better yield after application, and they're going to be able to know that using a multispectral sensor. So drainage, huge issue with any sort of crop, and multispectral can also help you plan how to drain, plan water management. This image shows 40-hectare soybean field here, and this was the same field. This is a field in South America, and it was flown at about 200 meters, which is, they're not purviewed down in the FAA down in South America. So pretty high altitude flight. This resulted in about a 6.5 centimeter per pixel GSD, which is super high resolution. Our sensors are phenomenal for covering really big areas like this and getting very high resolutions at the same time. Over here, this digital surface map shows the elevation variability in the field, which influences water flow and drainage. This data can be used in determining how you're going to plow, what direction you're going to plow, how you're going to plant seeds for the next year, and also how you're going to account for water management. In the case of irrigation, where you can often determine where there's less irrigation needed and where there's more irrigation needed. Sometimes you can be at risk. Multispectral sensors can actually help you determine where areas are waterlogged, and waterlogged areas in a crop field are pretty bad because they are usually accompanied by very high soil salinity rates, as waterlogged soils prevent leaching of the salts that usually are imported with irrigation water. So, don't salt your field if you're a farmer, right? That's what we don't want. And multispectral analysis can help you with that. So irrigation effectiveness, again, this is a huge issue. Water is primary, water is extremely expensive and necessary. So flying before and after irrigation can really help identify issues with either a sprayer. You can get clogged nozzles, just stuck or broken sprinklers. And you can do this by analyzing the temperature gradients within the field. Multispectral sensors are able to determine the differences in temperatures, and you can then go ahead and surmise what's happening there in the field. If you have a flooded area of the field, it will appear colder. So is water pooling? Is there water leaking from a center pivot irrigation system? This is the intention of flying our sensor over a field. It's all about what you know. And over here, you can see that there is some stress happening here in this pink area. This is effectively water stress. These plants over here are dry and hot, and they are not transpiring as they normally would. And so that's why they appear hotter. A plant that is transpiring and essentially breathing correctly will appear a little bit cooler on this type of map here. We got to take into account the canopy temperatures in relation to the ambient temperatures, and that's how you can go ahead and get the difference there, and then you can go ahead and guide a variable rate irrigation solution. Stand counts. Stand counts are having a heyday right now with machine learning algorithms able to do the hard work for us. Right here we have a eucalyptus plantation that's in South America that was planted with a ton of eucalyptus trees. For folks that might not know, a lot of tree planting operations have certain kind of contracts where if all the trees don't live, then people don't get paid. So if you are going to go ahead and plant, 10,000 trees and 5,000 of them don't take root and fail, then you won't be able to meet the terms of that contract and you might not get paid on that job. So we have customers that use our sensors to fly an established field and report back to the owner on how many plants are dead and how many plants are living. And if your job is to plant trees and then make sure that they live so you can get paid on the contract for those trees, a MicaSense multispectral sensor is going to be a great tool for you to get information about the health of these trees. So this is about a 1,300 acre field here. So the right image is obviously a zoomed in close-up image of that. So from the information in the image, it's possible to plan and manage replanting logistics if you need to, including assessing areas which the plants just didn't take root. Maybe they're not even worth replanting. It's also possible to determine how many plants to order, how much labor you're going to need to go ahead and put those trees in the ground. Many agricultural arborists have have the contracts that only allow full payment on healthy plants, as we discussed. So plant counting might be hard to tell, but we have 51,000 strawberry plants right here. The way we're able to get that number is by running these images through a machine learning application that will count the different pixels and determine if this is a strawberry plant or not. So this is a case study from a trial plot, a strawberry field, captured using a MicaSense Red Edge P. It shows the extremely high spatial resolution right here of this RGB composite image. These strawberries, the count could then be aggregated by row to identify areas of the field that are really performing the best here. So you can sort of see these high value areas are performing the best in this strawberry field. So this is really useful information to a grower because they're going to know essentially where to replant, where to focus their efforts, and where to spend their money. Additional use cases here. So there's a ton of different use cases. Multispectral thermal data, they're really useful for field trials, accurately determining disease resistance, drought tolerance. People want to run trials on new irrigation methods. They can determine the success of those methods using a MicaSense camera. I mean, water, environmental remediation, reclamation areas, there's all sorts of environmentally sensitive areas that need monitoring, recovery efforts after natural disasters. Maybe you live in California, maybe you're getting your 10th atmospheric river and you want to assess the damage to the levees and some of the waterlogged areas, around California. Let's go. MicaSense camera is going to be a great option for that. So we'll just go a bit into the product here. MicaSense cameras, as I've already said, offer extremely high resolutions and very narrow spectral bands for accurate data that can be used for time series comparisons, which means map after map after map after map. These are our two sensors that we currently manufacture. The Altum PT is our highest end sensor that includes a thermal camera to pick up on that long wave infrared band for a lot of different types of analysis, including yield and biomass. The Red Edge P camera over on the right doesn't feature a thermal camera, but still retains the panchromatic sharpening image techniques that we talked about earlier. So the sensor kits, and this is actually very important, MicaSense offers double calibration. What's better than single calibration? Double calibration. So we calibrate our sensors in two different ways. Before you fly a mission, you'll take an image of the calibrated reflectance panel, which is right here, which will effectively calibrate the different bands based on the environmental conditions, the ambient conditions happening at that moment. The second way we calibrate the images is using what we call the DLS2 sensor. This is an incident light sensor that comes with all of our cameras. And this mounts on top of the drone. And what does it do? It is constantly measuring the light from the sun and adjusting the contrast on the images. So this is very important if you're flying a large field on something like a partly cloudy day, where you can have a big cloud come over in the middle of your flight and produce a shadow over the field, and which is going to degrade some of that data. If you went and produced a map with that shadow, well, guess what? There's going to be a big dark spot in the middle of the field. The DLS2 will adjust the camera settings on the fly, real time, so that you don't get that inconsistent quality in the same flight. So the combination of the CRP, which is the calibrated reflectance panel, plus the downwelling light sensor, which is the DLS2, add up to an extremely precise camera. It's almost a scientific instrument. So why choose MicaSense? Accuracy, precision, repeatability, and hey, we're made right here. So, you know, we offer panchromatic band, which is a competitive advantage, offers extremely high resolutions. We're very accurate. We're calibrated. We geotag all the information on the images. And we're compatible with a very wide variety of drones and also processing platforms. So here's just a couple of our drone partners right here. We do have many more. If you guys are interested in what drones are compatible with MicaSense, I would encourage you to go ahead and contact Drone Nerds or MicaSense. We have that conversation. And that brings us to the end of the slideshow here. So Geo, without further ado, I might mute myself and have you pick it up.
All right. Yeah, sounds good, man. Thank you so much. Appreciate that, Nick. So we do have a bunch of questions from the audience, which is awesome. And I'll go ahead and read them off for you. Nick, you may want to actually take yourself off mute so you can answer the questions.
That would help.
Yeah, that works. Okay. So the first question we've got here is, what's the best and cheapest source for plant canopy indexing?
Yeah, plant canopy indexing would probably be an NDRE map. That's what I would recommend first on that. You know, plant canopy, what you're looking for is temperature variation on a plant canopy. So there's a few different ways to determine that, but an NDRE map is probably the best place to start.
Cool. Awesome. Thank you. Another one here. What indexes or spectral analysis methods are best for invasive species, such as arundo grass? I hope I'm saying that correctly. In river corridors.
In river corridors. Well, okay. So multispectral gets a little weird when you get into water. Water will effectively absorb light. So you can't really see into water beyond more than a few feet. And sorry if I'm misinterpreting the question, but if you're looking for like a river, like, you know, macrophytes or vegetation in a riverbed, you could probably do it with like a low turbidity stream, something that's really clear and not too deep. And with regards to identifying invasive species, you know, one thing that I'd like to mention is there are libraries with these spectral signatures of each plant species available on the market. So there's a company like a large tech company, Harris L3. They maintain what's called a spectral library. So you can go get essentially the spectral analysis of any different plant species. And then you can go ahead and use your drone imagery to look for the same spectral signatures. And you can determine, probably using a machine learning algorithm, what these plants are based on their spectral signatures when referenced with a spectral library.
Makes sense. Okay. All right. So two-part question here. Estimating yield with plant height has to be specific with crop variety. Is that correct?
It's best if you understand. Yeah, if you have a lot of different variety of crops all growing at the same time, it's going to be tough. More homogeneous crops, definitely able to get that yield number.
Okay, and the second part of the question, how do you estimate yield in trees, for example, almond trees, when height at maturity is reached?
You can do things like leaf analysis, and when a tree is actually totally mature, it will be a little bit more difficult because you don't have the differences in growth stages. And I would say biomass indicators using the NDRE map are probably the best way to determine a yield estimate in that way.
Okay. How did you create the CWSI index? Did you need some extra equipment or just a MicaSense camera?
Which index was that? The CWI?
CWSI.
Yeah, all of these images were just made using MicaSense cameras. So no, there was different processing techniques, but it's all from MicaSense imagery.
Yeah, the camera and the drone, pretty much.
Yep. Yeah.
Awesome. How can I extract temperature degrees from thermal images in individual trees, especially captured from a drone?
You need to compare the ambient temperatures, and the tree is going to have a temperature, the soil below it's going to have a temperature, the shadow of the tree is also going to have a temperature. So a lot of these processing techniques are just measuring the differences between those temperatures, and there's a few different ways to do it. The NDRE is probably a pretty good way to start on that. And you can then go to different thermal analysis, which will tell you the temperature gradients present.
Okay. Okay. What are the best indices I can use in early detection for diseases in palm trees?
Yeah, an NDVI would get you started there. And with regards to palm trees, you probably, because palm trees are big, I would also recommend an NDRE analysis as well. So you can compare the two, and when you're able to compare the two and see the differences, you're more likely to be able to see the areas, or like the palm trees in this example, that aren't working, that aren't doing well.
Makes sense. Okay. What processing software do you recommend, and what is the learning curve like?
Yeah, measure ground control. That is what I recommend. Yeah, I mean, there is a learning curve. As I was beginning the presentation, I do feel like it's important for everyone to know that capturing the data is the easiest part. Analyzing the data is the hardest part. There's different GIS schools out there. And also I think some of the processing software tutorials are pretty good. Pix4D, I think they're a fantastic company. They have great image processing tutorials, and their photogrammetry engine is phenomenal. So anyone looking to learn more about image processing techniques, I'd contact one of the processors for their tutorials. Yeah,
I would recommend both Measure and Pix4D as well, honestly. So what is the altitude to get images to calculate the replant index?
So altitude, it's really more what resolution do you need. With MicaSense cameras, you can fly higher and cover more area with very high resolutions. So if you had an alternate camera, you might have to fly that same field at a lower altitude to get that same level of resolution. And no one wants to be out there all day flying the field. So therein lies some of the competitive advantage of MicaSense cameras, is that they allow you to just cover more area and get more done.
Makes complete sense, and I completely feel that you don't want to be out there all day. Completely understand that.
Yeah.
Okay. Do you have any suggestions for machine learning software for tasks like plant counting and MicaSense imagery?
Yeah, certainly measure ground control can help you out with that. And also Pix4D can do some stand counts as well.
Awesome. Now this is a question that I've heard before, And obviously there's, differing answers sometimes, but so customers asking, does RGB not suffice for most agricultural applications?
RGB does not quite suffice. It depends on what level of analysis you're really looking at. If you have a normal RGB camera, you can get pretty close, but you have to remember that these normal RGB cameras aren't calibrated, and they're not extremely precise. So a multispectral camera is calibrated and much more precise. And what you're able to get with that is the full exploitation of like a machine learning algorithm. So if you ran an RGB image through a machine learning algorithm for a stand count, it just wouldn't have all the information it needs to accurately count everything in there.
Yeah, makes sense. Okay. Good question here. What are the deciding factors to choose the Altum PT camera over the Red Edge P?
Yeah, the big one I would ask a customer is, do you need a thermal band? So our, Altum PT uses a thermal camera from FLIR. It's a fantastic option. Not everyone needs thermal. Thermal and long wave infrared is really good at measuring biomass, and the physical reason is because a thermal band will penetrate multiple leaves. You can get a lot more information about the plant structure with a thermal band. So yield estimates can be improved. Like almond trees, for example, there was a question earlier about almond trees. You'd probably be able to get much better yield estimates using the Altum PT over a Red Edge P if you were looking for that.
Yep, that sounds about right. What is the lifespan of a multispectral camera?
Don't crash it. I'll say that. The lifespan, I think there's very few moving parts within either a Red Edge P or an Altum PT. We have customers now that use the previous generation Red Edge. It was called the Red Edge MX. And we have customers that have been using them for years and years, 4, 5, 6 years. So MicaSense cameras and multispectral cameras in general are not cheap. They are a capital investment in your drone business, but they are robust. They're designed to operate, in tough environments with dust and, hanging underneath a drone. So they're not as delicate as one might think, because there's very few moving parts. But yeah, if you have one strapped to an M300 and it comes down out of 400 feet, it's going to be a bad day if you crash it like anything else.
Yeah, you can't get any more clear than that, really. So a lot of people think that multispectral cameras are not useful for anything other than, let's say, grains or cotton or things like that. So this question actually may be up a lot of people's alley. Is multispectral data useful for vineyards, or is it mostly intended for grains?
Yeah, big time. Vineyards are like a grape has a tremendous amount of water in it. And so if you can go ahead and get information on how much water it has or how much water it does not have, you're going to be doing pretty good in your vineyard. So that is specifically where a multispectral camera can help a vineyard in that regard. We do have vineyard customers today. Vineyards in particular are usually, and specialty crops in general, are very high value crops. They're usually not extremely large. So a vineyard with a multispectral camera hooked up to like a quadcopter would be perfect. Whereas maybe a 400 acre cornfield might be a little bit more useful with like a fixed wing drone.
Yep. And that's funny because we actually have a question right after that. When would you fly a multispectral sensor on a fixed wing, and when is it better to fly it on a multicopter?
Yeah, no, it's a great question, really. And it just depends on duration, your endurance, how big of an area are you really trying to fly? Uh, you know, I like the phrase, nowhere is too far to walk if you have enough time. Well, it's kind of similar with drones. You could fly a quadcopter over a 400-acre field with a multispectral sensor on it. It's just going to really take you a while. It's going to, changing batteries and bringing it back. Whereas that same operation with a fixed wing drone could probably be done in about an hour.
Yeah, makes complete sense. Yeah. Okay. Can the multispectral easily detect man-made materials or objects that may be in a field or irrigation channel and need to be removed?
It doesn't inherently detect man-made objects. Multispectral sensors will measure the differences in the spectral signatures that it's seeing. So say you had a culvert that was filled with some sort of some vegetation in the culvert, but also in the culvert is a giant steel pipe. Those reflectance values would be present on any sort of processed map. Now, is the program going to tell you that this is a metal pipe? Not really. That's where you're going to need to turn on that big brain and determine for yourself what you're looking at, if it's going to be a man-made object.
Right. Yeah. Some thinking has to be involved for sure.
Yeah.
Do you recommend triggering by distance or speed with your sensors?
Automatic triggering based on waypoints is what I like. MicaSense cameras have an RTK compatibility. So we use a DJI piece called Skyport. So if people out there fly DJI drones and are interested in hooking up a MicaSense camera to it, get the Skyport additional piece. It will allow you to write RTK data onto that TIFF image. And when you have extremely precise location data, photogrammetry engines will produce much cleaner maps usually.
Okay. Question here: can these cameras spot genotypic differences in canopy temperature or spectral signatures in small experimental plots by 13 by 18 feet?
I don't see why they couldn't. A 13 by 18 foot plot, that's pretty small, right? So you might not need a drone, honestly, for that. We have customers that use multispectral cameras on poles that attach to a tractor. There's a few different uses out there. You might not need, certainly not a fixed wing drone, but a 13 by 8 plot, a multispectral sensor will give you valuable information. But the drone component of it, yeah, you might not need that.
Makes sense. Yeah. Okay. This is an interesting question. Does AgEagle have any plans to release a multispectral camera with more bands like the old Red Edge Dual, especially something that may be sensitive to SWIR?
Awesome. What a great question, my man. So yes, the answer is yes. We are working on a new dual camera based on the Red Edge P. We had the dual camera, for people that don't know, is a 10-band sensor. Typically, more bands, the better. 10-band sensor is going to allow you a wider range of spectral signatures and also more precision. So we do have plans to introduce a new dual camera. It's not determined exactly when it's going to be rolling out. I would expect some information in the next couple months.
Awesome. That's looking forward to that. So does the pan sharpening process not affect the original radiometry of the images, or are the analyses done on the original before the pan sharpening process?
It doesn't affect the calibration of the other bands. No, panchromatic band is its own band. I think of it as a sixth, the red edge P is a 5-band sensor, but the panchromatic band is like a 6th band. So it's a black and white image. And when you go into post-processing, it'll take that black and white image information and just combine it with either a blue or a green or a red picture taken on one of those wavelengths. And it'll merge all that information. So you end up with a lot more pixel information than you otherwise would. Panchromatic band also eliminates the need to fly an additional RGB camera and to process 2 sets of maps. A lot of systems out there, you'll process an RGB map and you'll process a multispectral map, and then you will merge them together. And that merging process can be complicated. MicaSense cameras don't need that because the panchromatic band essentially takes the place of an RGB camera.
Makes sense. Yeah. Okay. Couple more questions. We're running out of time here. Is it feasible to correlate plant canopy data to observed ground data on plant growth characteristics, in parentheses heights/nodes? In essence, are you aware of anyone who has developed a way using drone sensors to manage plant growth regulators, specifically in cotton, if I'm not mistaken, is what he's saying?
Yeah, just like checking out the growth rates of cotton, absolutely. You fly that field once a month, you develop like an NDVI or an NDRE map, and you'll absolutely be able to see the changes over time in a cotton field. That would be a really good application for a multispectral sensor, absolutely.
Cool. How does surface temperature from the Altum compare to, say, something like Landsat? Could it be used for scaling satellite measurements?
Typically, Landsat measurements they're not as precise as an Altum measurement would be. So I think Landsat is a good tool, but it just really depends on what sort of fidelity you need as a grower to make those decisions. For all intents and purposes, there's a lot of growers out there that Landsat or just other Earth observation satellites, they provide just quality data that, that's all they need. They're not looking for any more. But multispectral really comes into play with hardcore analysis. You have a lot of research facilities, you have a lot of different seed companies, and people that make it their professional business to understand whether or not this particular plant is healthy and going to make them money. So that's usually up to the user. How much information do they need? I know that there's a lot of growers out there that Landsat, it provides them as much as they need.
Makes sense. Yep. Last question here. What would be the lowest altitude that the Altum PT or Red Edge P can be flown?
So that is determined by the capture rate of the cameras. So Altum PT has a maximum capture rate of two captures per second. So if you were to fly, put the image in your mind of flying a fixed wing drone at 10 feet altitude, it's going to be flying much too fast, so essentially you have the same effect of slowing down by going higher. So you can't overspeed the camera, but I should say you can overspeed it, but you don't want to. And 2 captures a second is pretty good. That's going to allow a wide variety of speeds and altitudes.
Makes sense. That's usually how it is. You can't go too low or you're going to get blurry images pretty much.
Yeah, or you're going to hit that tree or that power line. We want to be above that stuff. Yeah.
Yeah, makes sense. Nick, again, thank you so much for joining us. We really appreciate it. I enjoyed this webinar. Agriculture has always been a favorite of mine. And for everyone out there, we apologize if we didn't get to your question, but if you want, you can send it to us and we can get it answered for you. It's not a problem. But thank you again for joining us all. Please stick around after the end and fill out our survey. And with that being said, we will see you next time.
Thank you.